Welcome to this Vue.js meetup, and thanks for having me. Today we're going to talk about security. So this is quite a special topic today. It's not so much about developing in Vue.js, but a security-related talk. I'm just going to present myself. I'm Tom. I work for a company or research center called SBA Research. It's a research center for information security located here in Vienna. And I do software security there, so software security consulting. I'm also a little bit of a software developer because I do an internal project for our company, and my front-end framework of choice is Vue.js. How could it be different? It's React. No, it's Vue.js, and I like that framework. I'm going to shine some light on some security topics today. I'm also one of the founders of Sec4Dev Conference and Bootcamp. I'm going to get back to this. What we'll cover today, there's going to be a lot of stuff, okay? I'm going to throw a lot of stuff at you. And don't worry if you don't get that all in all the details, but I want you to get an overview of what's relevant to you guys as maybe front-end developers or software developers. But first of all, I want to take a 10,000 meters view on the topic of software security in general, and then we're going to cover some things that are relevant in the browser. A specific attack or vulnerability called cross-site request forgery, and in order to understand what's going on there, we're going to clarify two very important terms for front-end development, which are the same origin policy, and explicit versus implicit authentication. You're going to see what that is. Then we're going to talk about CORS, cross-origin resource sharing. That's quite a difficult topic to wrap one's head around. At least it was hard for me to understand. And then I'm going to do a little bit of coding, live coding. We're going to code something or a little Vue application that has a cross-site scripting vulnerability, and I'm going to show you how to avoid it and how to fix it. And content security policy is a good defense in depth against cross-site scripting, the above. I'm going to tell about that as well. And then two more shorter chapters, cyber-source integrity, WebSocket Security. You're going to see this is a lot of stuff, okay? Don't worry if you don't get it all in all detail, but I want you to get an overview. So now before we get into the technical stuff, I personally think from my experience as somebody who works with software development teams all the time, there's no such thing as somebody who is a good software developer but bad at security. That never happens at the same time. It's basically one line in development in the software development world. So if you're a good software developer or you know everything in detail, your programming language, your framework, your environment, your build environment, your, I don't know, your operating system your software is running on, then you can judge the security of that software, of the piece of software as well. So understanding in detail means automatically being good at security. So learning in software development will almost automatically make you a better software or a security engineer, okay? So an in-depth understanding of all that's important for your software, the whole environment, including the framework, the language, everything, will almost automatically make you a better security engineer. Now, the information security community has two very big problems, and I have this tweet here, which I think is very true. I always have it on my slides. It says the number one problem in InfoSec is ego. So the hackers want to be cool and they want to hack some stuff, and you know. So the ego is one thing, but the second one is even more important. It's niche risk, okay? So if I work with software, when I work with software development teams, they always, or many times, they focus on niche risk, something that's not really important, but they forget about the basics. They do not really get the basics down in terms of security, but they have some shiny hack that they need to avoid. So that's also a problem. So let's get the basics right first, okay? The topics on the slides here are basically, they are basic security topics in browser security. So let's get them down first, and then let's focus on the smaller risks. The earlier in the software development lifecycle we find problems, and we detect security problems in our software, or bugs in general, or design flaws in general, the cheaper it's going to be, the less time and effort it's going to take to fix the problem, okay? So when you hear something like shifting left, it means that in terms of security, we need to start earlier. We want to start thinking about security already in the requirements analysis, in the design phase, in technology decisions, okay? So shifting left means starting earlier in the whole process. When you write down the requirements, the functional requirements for your software, security requirements should play a role as well. That's what this slide or shifting left is trying to say. So we need to shift left and start earlier thinking about these things. Good, so it's getting technical. The first vulnerability I want to present or show you is cross-site request forgery. Who has heard about this before? Who has had to fix it in your own software? 1, 2, 3, 4. Okay, I'm going to remember your faces. So in order to understand what's going on here, and in order to find an elegant solution against this problem, we need to understand two things, very important. The first thing is the same origin policy. What is the same origin policy? Now, the same origin policy is a security concept in web browsers that limits how one origin or one website that's open a tab, if you want to think about this this way, can interact with other origins. So a different website that's also open in the same web browser, okay? So there are limits in how they can interact. What's an origin? What does the origin consist of? Who can tell me? The host or the domain, yeah. What else? There are two more things. The protocol, so protocol and port. Exactly, these three things. If one of these three things is different, it's not the same origin anymore. So look at those examples. The first, so the starting origin is storecompany.com, accessed with HTTP, which I don't recommend, by the way, for the record. So we have the first URL example. It says HTTP storecompany.com. That's the same origin. The second one also same origin. The third one has HTTPS as a protocol. That's a different protocol, so it's a different origin. Okay. So the same origin policy applies here. The next to last example has port 81, so different port, different origin. So you get the point. These three things are important. It's the protocol, the domain, and the port. All must be equal. Good. Now, here comes the thing that is not intuitive. In the same origin policy, cross-origin writes are typically allowed. Cross-origin reads, on the other hand, are typically prohibited. And cross-origin embedding is also typically allowed. So if you have your website and you have a CDN where you include your Vue.js or any JavaScript framework or an image or a CSS file, that works, right? Even if that JavaScript runs on a different origin. Now, cross-origin writes, like form submissions, and that is the important part. Form submissions work cross-origin. Okay, I have an example for you very soon. Now, that's the stuff that's very important to understand and not intuitive. The other thing that we need to understand is implicit versus explicit authentication. Now, if an HTTP request is sent to a server, there are situations where the authenticating part of the HTTP request is sent by automatically. That's the case with cookies. Yeah. So if there's a cookie set for that domain, then and the request goes to the domain, it is going to be an authenticated request. It doesn't matter where it comes from. It can be from a different origin. It's going to be an authenticated request. Okay. The same goes for HTTP basic authentication, so where you get this small username password box where you native from the browser. You type it in once, and as long as your browser is open, these details are going to be sent by. Always, implicitly. You don't have to set it at each request. The same goes for TLS client certificates, but that's a rare case. So let's stick with cookies as the most important example here. Now, you could also have explicit authentication. So that's everything that's not implicit. So for example, you set a bearer token or a custom header with your session token inside. That's explicit authentication because you have to set that token at each request. In Vue, for example, if you use Axios as your HTTP client library, you can set this header. You can make a request listener and add this header at each request. Who has done this already? I have done this as well. So this is explicit authentication. It could also be in a body parameter. Well, it's everything that's not implicit. Good. Now, the cross-site request forgery attack works as follows. Let me give you this as an example. So on the left-hand side, you see the website that's open. It's bank.com. And you're logged in your bank account, and you can see the list of transactions in there. Now, on the bottom left, you can see that the bank.com cookie jar contains a session ID for that bank website. Okay? So within that same browser instance, if any HTTP request goes to https://bank.com, that cookie is going to be attached. Implicit authentication every time. You don't have to do this manually or anything. Okay? Now, an attacker lures you to a website that is under their control. For example, you get an email and you click on that link, or you get a message, you click on that link, okay? And it opens up in the same browser. Now we have a new tab. It's a different origin because it's attacker.com. I wouldn't call the site. By the way, this domain name is taken. I would take a different one that maybe sounds something similar like bank.com, bank with 2 Ks or anything, I don't know. I would just make up a domain that's similar. And in this website, we have an HTML document, and we have a classic HTML form. That form action, as you can see, points to bank.com. It says method post, and it has 2 input fields. It has the attacker as the transfer target, and it has an amount of 1 million, I think it's 1 million euros, okay? And here there's a little script. It says document.maliciousForm, refers to this ID here, .submit. So that form is going to be submitted, okay? What's going to happen? Do you think that cookie is going to be attached to the request? Is it even going to work? Yeah, it's going to work. Is it going to be an authenticated request? Yes, it is, because we said it's implicit authentication. It's going to be authenticated. So is this transfer going to be created? Yeah. So that's cross-site request forgery. Now, it's a cross-origin request, and the way we can do cross-origin requests, the ways are limited. But everything that can be done with an HTML form is still allowed for legacy purposes. You can have websites that do cross-origin login requests or anything like that. Okay, so that's still allowed. So this attack works under these circumstances. First, it must be write operation. So something needs to change when you send that request to the server. Otherwise, it's not going to have any effect. The thing is, if you send a GET request, it's going to be sent as well, but you cannot read the response. The response is not, cross-origin reads are prohibited, as we heard before, right? You can, here, for example, on the right side, you can make a little script that does an AJAX call to bank.com to get the list of the transactions, and the request is going to be sent, the request is going to be authenticated, but the response is not going to be given back to your script. You cannot read the response. It looks like an empty response, okay? So the attack only makes sense for write operations. It can be via GET if it's wrongly implemented on the server side, but mostly it's relevant for post requests, for creating a new object. Also, the server needs to accept the 3 standard content types that are supported in forms. There are only 3. HTML forms only can do 3 things. They can't do JSON. No, I tried it. It can't. It can be application form URL encoded. It can be multipart form data. What's the second one used for usually? For file uploads, exactly. And it's also text plain is also supported. That's the the parameter name and the value just one line after the other. So it must be write operation. It needs to be in one of those 3 content types, and it needs to be with implicit authentication. Otherwise, the request is not going to be authenticated. I cannot set a header with an HTML form, neither. Not possible. You can't do this. You can only set parameters. And when no standard header is required for that very same reason. Okay? I cannot add a non-standard header with an HTML form. That's why this cross-origin post capability is limited to requests without a custom header. So in short, anything that can be done with a classic HTML form is possible. Now, if you look at this a little closer and we want to come up with an elegant solution against cross-site request forgery, we can just set a non-standard header and we're done. We need to check on the server side that it's there as well, okay? But if I set a non-standard header and I check on the server side that it's there, no cross-site request forgery anymore. No CSRF token hassle. No cookies, no double submit request pattern stuff. You know, all you need to do is set, especially for Vue.js or any single page application framework, it's very easy to just set a header at each request. Very easy. So let me show you how we did this in our project. We said access defaults headers common this. Any header, it doesn't, the value doesn't matter. You can write anything in there. It just needs to have a value. We called it XSRF token, and on the server side, we just check that it's there. We say request headers has this header. Done. No tokens required. Okay? That's why I said if you take a step back and look into detail how same origin policy in this case and implicit authentication work, you can come up with elegant solutions that don't need any CSRF tokens. So, developer's checklist for a cross-site request forgery. The first step you need to do on the server side is strictly distinguish get from non-get. That's very important because there are different rules for get requests. Get needs to be get only, post only. Same for put, patch, delete, and all the others, but post is the most important one. And then either use explicit authentication, so if you have a bearer token, you don't have CSRF neither. You can throw away all your tokens if you have a bearer token, okay? Throw away all your CSRF tokens, I mean. You could also include a per session CSRF token, but that's the complicated solution that we want to avoid. Or you could also only accept a non-standard format. So if you only accept JSON on the server side, no cross-site request forgery possible, because I cannot set a JSON content type with my HTML forms. So CSRF is not possible. Or the simplest of all of these is just set a custom header and check if it's there on the server side. Done. Okay. You could also combine these, but not necessary. Also, as a good defense in depth, you could set the same site cookie attribute for your session cookies. The thing is, it's just not supported in all browsers. It even got backported to Internet Explorer. That's no joke. It really got backported. So you have a pretty broad support already. That cookie attribute or cookie flag, what it does is, let's go back to this slide with the example. Imagine on the bottom left, the session ID cookie. If this cookie had the same site cookie flag set, it would not be added to this request of the form here on the right side because it's same site. Only requests that originate from the same site are going to be authenticated. All right? Just browser support is not 100%. That's the only downside here. Good. Brains exploding or brains okay? Okay, they will explode. Here, cross-origin resource sharing, because this is brainfuck, pure brainfuck. I want to help you through this because it took me years to wrap my hand around this, and that's why I want to help you. Now, imagine, for example, you have a website that runs on example.com, and you have your backend API that runs on api.example.com. Now, that's two different origins, and the same origin policy applies, so you cannot send a GET request to your API because the browser is going to prohibit that. Now, in order for this if you want to make this work, what you could use is cross-origin resource sharing. Okay, so what it does, it drills holes into the same origin policy in a controlled way. You can open up cross-origin requests in a controlled manner. For example, look at this request on api.example.com here on the bottom. In the response header, it says access control allow origin. And this allows the origin example.com to access the API with GET requests, for example, and also other POST requests, all types of requests, actually. Now, there are two types of requests that play a role in cross-origin resource sharing. That's simple requests and preflighted requests. Now, simple requests are just the ones, basically, that do not change anything on the other side. We have, for example, a GET request to the URL bar.other, resources something. It's a GET request. We have no custom header set or anything. Now, if that request is going to be sent to the server, a browser that is capable of cross-origin resource sharing is automatically going to add an origin header. So the very last line on this slide, it says origin http foo.example. That header cannot be manipulated via JavaScript. You can try it, it's not going to work. Okay? So that header is going to be sent by. Now, if the server sends back an access control allow origin with either an asterisk or the explicit host, what's going to happen? We said before that the request is going to be sent anyway. It's going to be an authenticated request and everything. But what's the difference with this header? Say it loud. It's gonna give the ability to read the request to the originating JavaScript. That's the only difference. Okay, so you can actually read the GET request, the response to your request, which would not be allowed by default because of the same origin policy. Cross-origin reads are typically disallowed. Now we also have preflighted requests, and those are requests that, for example, have a non-standard content type, like XML is not a standard content type that can be done with a form, or you have a custom header set, or a combination of those things. Now, if this happens, let's have a look at what happens in the browser. These are the two non-standard things. If you send this request via JavaScript, then the browser is going to be issuing a pre-flight request. So it's going to ask the server, look, server, this is what I'm about to send you. Is this OK? Right? A post request would automatically create an object on the server side, for example. And when the browser sees, OK, this is a post request that could change something on the other side, it's going to issue an options request and ask, look, this is the origin I'm going to send the request from. I want to send a post request, and I have these two non-standard headers that I want to set. Server, is this OK? And then if it is OK, the server is going to answer this back. It's going to say, access control allow origin, the originating origin. Then it's going to say access control allow methods. These three methods are allowed. I can take them. Access control allow headers. So these two non-standard headers that you're about to send me are OK as well. I can accept them. And there's one more thing, access control max age. What do you think that's going to be? No. It's about caching, exactly. So that the server doesn't have to ask this same question for each post request over and over again. The server tells the client or the browser, remember this information here for the next 86,400 seconds, which is, I don't know how much. It's 1 day? Yeah. I think it's 1 day. OK. And only then, if the browser sees that the server accepts those rules, it's going to send the actual request. So the access control request header is not set anymore here. So this is the actual request. So standard request is just going to go through, and the server decides whether the response can be opened up to the originating JavaScript. If it's a request that could change something on the server side, such as a post request or something with a custom header, then it's going to ask first with this options request. You might have seen this in your network tab and ask yourself what that means. So that's it. It's asking the server whether it's OK to send that request. Good. So just a little checklist for you. If you have, for example, your frontend on your backend on different origins, don't just set access control allow origin to an asterisk everywhere, because that's going to open you up to cross-site request forgery attacks, the one that we saw before, including read access. So it's, next level cross-site request forgery, if you will. We don't want this, OK? Always just whitelist specific origin headers. Have them in a configuration file somewhere, and if the origin header is one of these, send that same header back. Don't just reflect the origin header, because that's the same thing as just setting an asterisk for everybody. Check that in your environment if you have set this, because this could be dangerous. It might pop up in the next penetration test. Don't push the development environment settings to production, because they could contain something like this, because in your development environment you might want to be able to just see everything. So whitelist the allowed origins as a configuration parameter, and whitelist only allowed methods and headers. Just make sure not to open up everything. Yeah?
So, but the cause generally is protecting the user in the browser, not the server, and not the backend. Because I could do all these requests via kernel, and then cause would be completely ignored.
Sure. The only thing it does is it's protecting the user. Yeah. Of course, in a curl request or curl command line environment, you have everything under your control. So if you put the session ID in there and the headers and everything, of course it's going to work. Yeah.
That was something
If you have more questions, please save them till after, because they don't translate to the recording at all, because they don't understand what we're talking about. But just keep them in your head, and he's available for questions at the end.
OK. Good. Cool. Now comes the most important topic in front-end development, which is cross-site scripting. Who of you has heard of cross-site scripting? Who has fixed it in their application? That's less hands than before. Who has exploited it somewhere? I have as well. I do that every day. Cross-site scripting. Now, this is going to be Vue.js specific, so let me show you a little demo on this. I have created a little application, and I want to show you a couple of pitfalls that are important to you as Vue.js developers. Now, when you want to avoid cross-site scripting, it's basically only two things you need to watch out for. The first one is v v-html. What does v-html do? And which property is that? Which DOM property is that? Of the element? Element dot, what is going to be doing in the background? Inner HTML, exactly. So v-html leads to an element.inner HTML in the background. Now, if you set inner HTML, it can contain HTML, and HTML means it can also contain scripts. Okay? So the whole thing is about when you have a value, for example, this value test here, which is defined on the bottom here in the data. When this value is under the control of an attacker, it gets dangerous. Think, for example, of a case where you have a messaging application and you can send back and forth messages to each other, and those messages can be formatted. You can make bold text, you can make unordered lists and all these sorts of things. Now, if you don't do anything and just create an element for your message div and do inner HTML or v-html, you're going to have process scripting, because then an attacker or the other side of the other user on the other side can just create an HTML including script tags. When you open the message in your application, that script is going to be executed in your user context. That's what it's all about. They want to interact with the application pretending they are you. Okay? So it is important that when a value that falls into v-html is controlled by an attacker or another user. Just let me show you an example. We have created a little text here that contains such a formatting. It contains a strong text, and if you look at this side over here, you can see that the example where it is bold. Okay, let's just try out what happens if I say, for example, if I save this, okay. Let's try script tag. There's an error, syntax error somewhere. What does it say? Do you see error? Just going to put it back to where we were.
Maybe the semicolon? Yeah.
Could be. That's really weird. Okay, there you go. I don't know what was wrong before, but you can see that this alert one is going to be executed once I open up this site. And the on error just fires because source equals x just doesn't exist. So the on error event handler is gonna fire, and that contains or can contain JavaScript. It will contain JavaScript. Okay.
The problem was maybe that in the p tag you cannot input a script.
That could have been a problem, yes. That's why I like the image tag more, because it works in more situations when I do pen testing, actually. Yeah. So v-html does not have any sort of filtering or sanitization or anything. Now, how can we solve this problem? In this case, when we need HTML in our elements, we need to do sanitization. So we need to make sure that only the parts of the HTML that are allowed, that do not contain any JavaScript, are filtered out. Okay? It's not only, don't think just about script tags. There are many places in HTML where script code can live. It can be JavaScript event handlers. There's on mouse over, on key up, on key down, on error, on body load, whatever it is. There are many, there are 200 and something, I don't know, many JavaScript event handlers where JavaScript code can live. Good. So one library that we could use for sanitization is, it's already imported here, it's DOM Purify. That's a very good library. It's written in JavaScript, and it takes HTML and filters out the bad parts. So everything that could potentially contain JavaScript, and that's way more than you would think. And it's very hard. Don't roll this on your own. It's very hard to do. Let's try this out. So instead of just taking test here, let me just write the text before that image shows up here. I have this function down here that's called purify and takes a text, and it returns DOM-purify.sanitize. So it sanitizes everything that could contain JavaScript out of there. So what I do here is purify, and I pass the text. No, it's test. Save it. And it still works. So the text is still there, the image is still there, but you don't see the pop-up anymore. So if I have a closer look at this element here, let's inspect this image here. It says here, image source equals X, and there is no on error anymore. So it filtered out the potentially dangerous parts that could contain JavaScript. Of course, in practice, what you would do, you would not include this function or write this method for each and every component that you do. You might have a custom directive or anything that you can use in all parts of your application. Now, this is the one thing. So be very, very, very careful with Vue.js-HTML, especially if the input can come potentially from an attacker. Okay? Use it with care. And if you use it and the input is typed by a user, then please use something like DOM-purify to put out anything that could be dangerous. Now, the second thing I always ask JavaScript or front-end developers not to do when using a single-page application framework is DOM Kung Fu. I call it DOM Kung Fu. DOM Kung Fu means bypassing the standard Vue.js way to do something with the DOM. And I have two examples down here. Now look at this. There are many XSS syncs, so functions that take a string, and if that string contains JavaScript, it's going to be executed. One is the function constructor. Right? I have this mounted function here that is called once that Vue.js component is mounted. When I save here, what happens again is I have the alert1 box on the right-hand side. So this is just one potential sync. So who of you knew, for example, that set timeout also can take a string, not just a function as the first parameter, but also a string? Comment this out, save it again. What happens? I have the alert box again. And there are about 65 such DOM XSS syncs in the DOM API. 60 something. Not just these two, there are 63 more. Okay? Don't do this stuff such as document write, new function, set timeout and set interval with a string passed to the function, and so on and so forth. So if you want to have a look on GitHub, there's a project called it's called DOM XSS Wiki. There are lots of huge list of DOM XSS syncs that could bite you when developing with Vue.js. So to sum this up, when you code with Vue.js in order to avoid cross-scripting, it's basically two things. Vue.html, be very careful and purify the input. And second, don't do Kung Fu. Just take the usual template syntax to output stuff. Don't do things like, creating a new function this way or doing document write. Okay? Good. So Vue.html is the #1 DOM XSS sync in Vue.js. Avoid the Kung Fu stuff that I just showed you. Also, don't render the template server side. Now, there's one thing that could get dangerous if you render your templates on the server side and you have, for example, an HTTP parameter that gets directly, you put it directly into the Vue template. There's something that could bite you because in the template, I'm going to show you the example. I have it open, I think, here. Now, what does that do? So imagine you have a template that it's not static, but it's dynamic. This part here is taken on the server side from an HTTP parameter and it's put in there. So the parameter can be controlled by an attacker by crafting a URL that contains this, what I have marked here on the left-hand side. So they can potentially write something in there that also leads to the direct execution of JavaScript without changing anything that's down there in the controller. Okay? So make your templates static always. Don't make them dynamic by any HTTP parameters or anything like that. That's just dangerous and it's going to bite you as well. So keep them static. Also, be very careful with external libraries because they might do that dumb kung fu stuff as well. So there could be known vulnerabilities in your external libraries. Check them for known stuff from time to time. You could use npm audit or any other software that checks your dependencies for known vulns. Good, so we've talked about cross-site scripting. If you have huge applications, it could be very hard to avoid cross-site scripting in every part of your application. You could also use tslint or eslint to prohibit some of those functions so that at least you get a notice when you use them. But a very good defense in depth against cross-site scripting is the content security policy. Who has implemented a content security policy of you? So it's 2 people, 2.5, 3 people in this room. Now, I have a famous site here that says it's not a matter if you will introduce a cross-site scripting vulnerability in your applications, but when. Okay? So the more complex your applications are, the more likely it is that sometime you're going to introduce cross-site scripting. A word of warning before you start implementing a CSP is it's not the solution of cross-site scripting. It's just a defense in depth. So correct output encoding or using your single-page application framework such as Vue.js the correct way is of utmost importance still. Okay? It's only a second layer of defense. So what is a content security policy? It is a new HTTP response header that you can add on the server side in your application or maybe also in your web server. You can just statically set it as a string. And it's basically a whitelist for dynamic resources. So you can tell your HTML. So when you send an HTML back to the web browser, with Vue.js applications, you usually do this only at the first request. You're going to tell the browser, look, for this HTML here, you can only get the JavaScript files from this and that server, and you can not use any inline CSS or inline JavaScript. Okay? That's what you're telling the browser. That makes cross-site scripting way harder because think of the example that I showed you before, the image tag on error equals something. That's an inline JavaScript. It's in HTML. With a standard content security policy like it's defined here in the first code line, inline scripts are not allowed anymore. They are prohibited. That's the main part of a content security policy. So look at this example here. With this content security policy in the first code line, script source self and cdn.example.com, we tell the browser, look, if you load scripts, you might only load them from self, so the own origin, or from this CDN over there. Nowhere else can you load scripts. Now, if we have this HTML including the 3 scripts in the middle, the first one, is it going to load? Yes, it's going to load. What does // mean without any protocol? It takes the parent protocol implicitly, so yes, it's going to work. The second one is just an absolute path after the origin, so it's going to work as well. And if I include evil.com ownage.js, it's not going to work because it's not whitelisted on the top. So it's going to issue an error message like the one at the bottom. Now, the core and heart of content security policy is that inline scripts are prohibited by default. Right? So if you do something like this, script, new image, whatever, it's not going to be executing because inline scripts are prohibited. Inline scripts is what mostly happens when a cross-site scripting attack takes place. Okay? So also disallowed are event handlers in attributes because they are also inline JavaScript, such as on key up, on key down, on error. They are prohibited as well. And unsafe functions like eval, set timeout, and set interval. I showed you the example of set timeout. It takes a string directly and it can execute JavaScript. So it's going to be disabled also. AngularJS version 1 did not work with the content security policy like this because it used eval a lot. Okay? Starting from Angular 2 and also Vue.js, it does work because they don't use eval anymore. Good. So there is a cool thing about the content security policy if you want to get started with it, and it's called the report-only mode. Right? So you can implement a content security policy without actively blocking any scripts, but still you get a notice if a script would have been blocked. So if you have a big website where you're not sure if some part of the application is not going to work anymore because there might be some inline script somewhere, you can implement the content security policy and add the report only without the brackets, just the dash report dash only. And it's going to report to the URL that you specified in report dash URI. So if some script is blocked, it's going to tell you, it's going to send JSON like this and tell you which site it was and which script it was. There are free services online that you can register to make a reporting server. You don't have to set up your own reporting server. There are ready-made projects for that. Strict dynamic is a cool thing where you can also tell the browser. You remember the DOM XSS things like set timeout, set interval, and stuff like this. With strict dynamic, you can tell. No, sorry, I'm confusing two things here. Strict dynamics means if you have a script that is already trusted, that script can load other scripts. Okay, so if you have a script like script.js and that's going to load other scripts, with this directive, strict dynamic, you can whitelist the scripts in there. Good. Extract or your inline scripts, it's easy with Angular or Vue.js or any single page application because you don't have any inline scripts usually. If you fire up a standard Vue.js project, it's going to be, you have your app bundle and your vendor bundle maybe in there, and that's it. It's all external JavaScript files. And they are, if you have a content security policy with script source self, it's going to be whitelisted anyway. Okay? So with single page applications, this one is very easy. That's why I'm telling you to do it. Then analyze where the dynamic sources might come from, inline scripts and also script source something. Define the directives. Maybe start with report only if you have a more complex application and you want to know if it works or not, if you have any violations. Start testing and then activate it by putting a directive without report only. But I would keep the report URI because a violation is going to be reported. So if there's a cross-scripting attack happening, you're going to know. And it's good to know that. Okay? So put the report only away once you gained confidence with your content security policy, but keep the report URI. Again, this is not the first line of defense for cross-site scripting. It's the second line of defense, so defense in depth. Good. Still able to listen, and I see the brainfuck level is going up to 9 out of 10 for most of you. Two more things, okay? This is an overview. Don't worry if there's something that you couldn't grasp 100%. One cool thing that you can use if you're using a CDN, a content delivery network, to load your scripts from an external provider is sub-resource integrity. Now, imagine the following. If a content delivery network gets compromised, and that happened in the past, then your site might be compromised as well. Because if it loads a script from there and loads it into the context of your site, it can potentially execute anything in the name of your users. And if that's thousands of users, that could be important. Okay? So this is the risk. The content delivery network itself could be compromised. Now, what sub-resource integrity can do for you is it adds an attribute called integrity. So say, for example, you load Vue.js in the version 2 point something, 2.1.1, and you know the script is going to look like this exactly. It's going to have this content. It's not going to change because the version is fixed. Then you can calculate the hash of it and put the hash into the script tag. That means that browser loads the script. It's going to check if anything has changed. If 1 byte in there changes, it's not going to load the script anymore. Okay? So if somebody manipulates the script at the content delivery network, your site is not going to work anymore, but at least no one can attack you. Okay? So it's an integrity check for your scripts. You don't have to calculate the hash on your own. You could do it in a command line, but there are websites like, for example, subresourceintegrityhash.org, where you can just put the URL of your script inside, and it's going to output the script tag, including this integrity. Also, word of warning, only do this if your CDN supports it. If they give you the script tags, including that integrity parameter already. Because they might, for example, I don't know, change the minifying algorithm of that script, and then that's going to violate the integrity as well, and the script is not going to load anymore. If we have a look, for example, at the jQuery CDN, they have this already included, so they actively support sub-resource integrity. Okay, so have a look. Don't do it on your own, maybe on your own server that you have under your own control, but not just for a random CDN, just for the ones that support it, and then use it. Now, just one essential thing, basically WebSocket security, there's one thing that's the most important one, and it is checking the origin header on the server side. So if you do a WebSocket connection to a server, make sure that on the server side you check which origins you trust for WebSocket connections. Okay. The scenario where, for example, imagine the same scenario for the bank. You're logged into your bank website, and they have, for some reason, they have a WebSocket connection, for example, for a chat. Okay. Then the attacker lures you onto a different website that they have under their control. Now, if you're logged into that website, you can open up a WebSocket connection to bank.com, and it's going to work. The same origin policy does not forbid this. Okay? For WebSockets, the rules are a little bit different. So on the bank.com side, on the server side, you need to check that origin header. It's going to be set. It cannot be manipulated by the attacker's site. Good, so that's it. Let me just wrap up the contents of this talk. So when you want to be good at security, just to make sure that you have an in-depth understanding of your development environment. That means your programming language, your framework, the web browser as a platform for your website, because understanding those things in detail will almost automatically make you a good security engineer. There's no such things as being a software developer and being a good security engineer. It's almost always the same thing. It's a linear development. Get the basics right first, so care about cross scripting. I want all of you who have developed a Vue.js application to either now or later do a Ctrl-Shift-F v-html enter in your environment, and have a look if the value that gets in there might be controlled by an attacker or by a different user. That's a very, very basic thing in front-end development in terms of security. This is the first thing I ask you to do. Let's get the basics right, and let's share how we do this. Also, shifting left means thinking earlier about these things. So making the right technology decision, a good architecture is also important for security. And it's going to save you time and money if you don't do it later on. Let me just wrap up the technical topics that we did. Cross-site request forgery. Remember, everything that can be done with an HTML form on the server side and is accepted by the server side potentially opens you up to cross-site request forgery. So someone lures you on a site that under their control and issues a cross-origin request. Cross-origin resource sharing lets you open up the same origin policy in a controlled way. So if you have your frontend and your API running on different origins, you can allow some requests and you can control that. Cross-site scripting, two things are very important. First, when using v-html, be careful where your input comes from. If it's potentially from a different user, make sure, or just purify it anyway, okay? A content security policy is a very good defense in depth. It controls where your dynamic scripts or dynamic parts of your application might come from. Sub-resource integrity makes sure that the Vue.js that you load from a CDN does not get changed there or when the CDN gets compromised. And with WebSocket security, it's very important to check the origin header on the server side. Who is using WebSockets? The first thing you do at home is please check the origin if you have checked it on the server side. Good. We also have a meetup that's about topics like these. So a security meetup by my company. Nikki and me organize it. Nikki is here as well. Where's Nikki? There he is. So this is the guy. We had, for example, the last meetup was about Kubernetes credential management. We had one about application security design patterns and things like these. So if you're interested, make sure to sign up. Also, we organize a conference, Sec4Dev Conference and Bootcamp, where that's a conference about security, but specifically for developers. It's not a security conference where security people like me gather and talk about the latest hacks and cracks. It's not about that. It's about taking away useful stuff for everyday software development lives. So make sure to follow if that's interesting for you. Thank you very much.